In geotechnical engineering, unit weight is a key property when analyzing stress, stability, and bearing capacity of soils. Natural unit weight, also called bulk unit weight, is the weight of a volume of soil in its natural state, including solids and water, divided by its total volume, solids and voids. In this video, all measurement procedures are intended for educational purposes only. It's important to emphasize that, in geotechnical practice, the determination of soil physical properties must comply with current local standards using appropriate and properly calibrated equipment and carried out in controlled environments. To measure the natural unit weight in a simple lab setup, we use a regular shaped soil sample, such as a cube with a predefined weight and internal volume, and determine its weight and volume. The natural unit weight gamma is calculated by dividing the total weight of the sample by its volume. Now let's understand the submerged unit weight. In this setup, the soil is completely surrounded by water, that is, it's submerged. However, being submerged doesn't mean the soil is fully saturated. Some air might still remain trapped in the pores. The submerged unit weight refers to the effective weight of soil in water. It's calculated by subtracting the unit weight of water from the natural unit weight, but only when the soil is fully saturated, 100% saturation. To determine the saturated unit weight, we first measure the total weight of the theoretically saturated soil sample. We then carefully dry the soil to determine the weight of the solids. For this educational demonstration, the sample is left under the sun for several hours, allowing part of the water to evaporate. While this method doesn't remove all the water, it helps illustrate the basic concept. In professional laboratories, however, drying is done using a controlled temperature soil oven. After drying, the soil sample is gently crushed into fine particles. The powdered soil is then placed into the standard cube used in this experiment to measure the weight of the dry solids. The dry weight corresponds to the solid's weight, while the difference between saturated and dry weights gives the weight of water. Finally, the saturated unit weight is calculated as the sum of solids and water weights divided by the total volume of the sample. While geotechnical engineering includes other forms of unit weight, the three introduced in this video will serve as the basis for the applications we'll explore in the next episodes. Thank you for watching. For more practical geotechnical demos, follow the channel GeoSolved.